So let's talk about electricity then. So we've looked so far at static electricity. We've looked at electrons not moving. Yeah, so electrons not moving is just static electricity. If you've got lots and lots of electrons built up in one place, you've got charge. Each of those electrons carries a certain amount of charge, and it's negative charge. Okay. Now, in normal electricity, if you move those charges around, say, a circuit, then you've got electrical current. Yeah, you've got electricity that's moving, current electricity. Yeah, so there's three terms that we need to know about in order to understand current electricity. So potential difference is the first term. Sometimes we call it voltage. Okay, you might have heard it used interchangeably at GCSE level between potential difference and voltage. So potential difference, I like to think of it as the amount of push that you're going to give these charges. So how hard you push them, in other words. Okay. The more technical way to describe it would be the amount of energy that you give to the charges. So amount of energy, let's write this. So energy given to charges. Okay, you push them harder, they'll flow faster, right? Well, this is measured in volts. Okay, so energy given to the charges, the push that you give them, measured in volts. Okay. Current then is, like we said just now, potential difference. If you give them more potential difference, then you're going to push them harder. They're going to flow faster. So this is what current is. Current is the flow rate of these electrons, or the flow rate of this charge, the amount of charge that passes through a certain point in a circuit in a second. Okay, so the flow rate of charge. Let's write this down. Of charge. Okay, so those negatively charged electrons, if you've got loads and loads and loads of them moving through a certain area of your circuit, then you're going to have a high current. Okay, this is measured in amps. And finally, we've got resistance. So resistance is a property of devices in your circuit that is going to try and resist that flow of charge. It's going to try and reduce the current. So this is a resistance to the flow of charge. Okay, so that's what our resistance is. Resistance to flow of charge. Okay, and this is measured in ohms. Okay, so there's a device that we can use to reduce the current in a circuit without affecting the potential difference. That device is called a resistor. Okay, every device that you connect in a circuit has a certain amount of resistance, and that's just used to reduce the flow of charge around the circuit. Okay, let's try to make this a bit more clear then with an analogy. So, if you think about the electrons as water, okay, we can think about water. We can think of the electrons, pretend that it's water for the time being. Let's use this analogy where you've got, say, some water flowing around a closed loop pipe, yeah, like this. Now, if you didn't have a pump, then that water would just sit there. There wouldn't be any current in there, would there? But if we add a pump, okay, this pump is like our battery. Okay, so this is like our battery or like our power source. Yeah, this is going to cause the water to want to flow around the circuit. This is our battery. Okay, it's providing potential difference, let's say. So let's say it's providing some energy to the water in order for the water to flow around the circuit. So this will pump the water around the circuit, okay, like so. Yeah. If the pumps span faster, yeah, then this water will flow faster, the current will go up. This is like in a circuit, if you increase the potential difference, then the electrons will flow faster. Yeah, the charges will flow faster. In this circuit, we've got a pump. Turn that up, the water will flow faster. So the pump is like the battery, the thing that gives the circuit potential difference, and the flow of water is the current. Well, how do you think we can model resistance then? Let's think, how could we slow down the flow of water in this circuit without changing the potential difference, without changing the pump speed? Well, one way to do it would be to take the pipes and make them narrower. Yeah. So if we made this pipe narrower, if we took it and we made it narrower at a certain point, let's say just there, okay, so we've got a very narrow section of pipe there, then the water's going to struggle, it's going to build up here and it's going to struggle to flow through this pipe here, yeah? So this is going to slow down the flow of water in our circuit, okay? This will slow down the current. This is like our resistor. So this sort of models resistance then. So we've got the pump modelling potential difference, okay, modelling our voltage. We've got the water that's modelling our current, yeah, current. And we've got a thin bit of pipe here that can model our resistance, yeah. So if we, that's my analogy for electricity flowing around a circuit. Okay, so just a real quick recap. Potential difference, push the electrons harder, they will flow faster. Yeah, if you added resistance, then that's going to cause the current to go down. Lots of resistance, low current. Not a lot of resistance, high current. Okay.